Hey guys, welcome to our video lesson on absolute value inequalities. This is target 5C, our last target in this chapter. So we've talked about individual single variable inequalities and compound inequalities. So let's talk about now what happens when we have an absolute value bars added to our inequalities here. So we're always going to go back to assessing what is absolute value inequality or equation or whatever telling us, right? It's telling us something. This is telling us that x, oops, sorry, let me get my pen's going here. This is telling us that x is more than 6 units away from 0, right? So if you think about that, what numbers could that be, right? What numbers are more than 6 units away from 0? Well, 7 would be more than 6 units away from 0, 8, 9, and so forth. But also -7, -8, -9 are all, right? We also have decimals in there. What about 6.5? What about 6.2, 6.1, right? So if you look at this graph below, this graph here kind of shows what we're looking at. We're looking at every number that is larger than 6 and every number that is smaller than -6. All of those numbers would be more than 6 units away from 0. All right, so what we've now actually created by looking at it this way is that we have two inequalities. So the solution is represented by two inequalities. We have x being greater than 6, and we have x being less than -6. All right, so the graph represents and notice we're not looking for where they're overlapping each other. We're looking for a union of those. We're taking anything from either of these. And so that means this is an or compound inequality to put these two inequalities together. So this graph represents us forming a union. So that means we use the word or in between our two inequalities. All right, so let's look at a different one here. What is this second one communicating? It's saying that x is less than or equal to 6 units away from 0. So again, what numbers could that be? Well, that could be 5, 4, 3, 2, 1, 0, -1, -2, -3, -4, -5, and of course all of the decimals that are in between all of those integers. But if you notice, one more number we can add to the list because it's equal to could also be 6, and it also could be -6. Right, so if we graph those, what we see here is essentially x is less than 6. We also see x is greater than -6. Now notice here what we're really looking at is an intersection, right? And so we're going to use the word and because we are forming an intersection. All right, so we use the word and. All right, so again, we can see that understanding these sentences is going to be telling us what word to use to join these two separate inequalities together. Because we know with absolute value, there's always two directions. Even with equations, we always had two solutions, except for our special cases. But we had two solutions, so we're going to have two inequalities. So we've got to stick those inequalities together somehow. And we can see the key here, again, if we have a greater than symbol, we're looking for more than away from 0, which causes us to use an or, the word or, because because we're dealing with a union. When we have a less than or equal to, all right, we're dealing with, again, less than, right, which means we're using the word and because we're creating an intersection there. So let's apply this now to a problem that's just a little bit more complex. So we have the absolute value of x plus 5 is greater than or equal to 11. So this is saying x plus 5, oops, let me go back to black pen here, is more than or equal to 11 units from 0, right? So again, what word are we going to use to join our two inequalities? When we're dealing with going further away from 0, we're not going to be creating an intersection because the two inequalities are going to be going away from each other. We're going to be creating a union. So we're going to use the word or, right? So now let's think about the two inequalities that we can create here. X plus 5 can be more than 11 units or equal to 11 units away from 0 by being larger or equal to positive 11, or x plus 5 can be smaller or equal to negative 11. Those are the two possible ways I could end up with numbers that are more than or equal to 11 units away from 0. So when I solve these now, so if I subtract 5 from both sides, we'll just change colors here. I'm going to get x is greater than or equal to 6, or when I subtract over here, I'm going to get x is less than or equal to negative 16. So you can see down below, I've kind of already set myself up for what we're doing here. So I'm going to have a closed circle at 6 because it's equal to, and I'm looking for all the values greater than that, right? And I'm going to have a closed circle at negative 16, and I'm looking for all the values less than negative 16. So I'm going to, since it's an or, I'm going to be taking the union, which means any number that is 6 or bigger would make this inequality true, and any number negative 16 or smaller would make the inequality true, right? And that's, again, an important thing. The shaded numbers will make the inequality true. That's what we're finding by doing this. We're finding the numbers that will make the original inequality we started with there true. All right. So what we're going to be doing now is we're going to be solving the inequalities. We're going to be graphing them. We'll be writing our answers in interval notation here. So we can see. We'll look at this example together here. Let me just scan down. I kind of forgot how many examples there are. Yeah, we'll do these two together, and then there'll be 4 for you to work on your own. All right, so we can see that we have that less than symbol, right? So less than is telling us we are going to be creating an intersection, right? Because we're going to be looking at values that move towards each other. So I'm going to be using the word and, right? Less than is telling me I'm creating an intersection, so I'm using the word and. So that means 6 minus 3 has to be less than 15 units away from 0. So that means it can be less than positive 15, and it can be greater than negative 15. Those are the two possible ways that numbers can be less than 15 units away from 0. So I'm going to solve both of these. I'll get 6x is less than 18 by adding 3 to both sides. Divide by 3, x is less than 3. And over here, add 3 to both sides, right? I'm going to get negative 12. Divide by 6, and I'm going to get negative 2. All right? So we can come down here now, and I can graph this. So I'm going to put negative 2 over here, negative 1, and negative 3. So I have my integers around my values that I am starting my graphs at. All right, let's switch here. I'm going to be an open circle at 3, and I'm less than 3. I'm going to have a open circle at 2, and I am less than 2. So where do those graphs overlap each other? Where is there an intersection? Well, there's an intersection right there. All right, so now we're not done. Now we need to turn this into interval notation here. So we can see our shaded area, our solutions, are starting at negative 2 and going to positive 3. But because of the open circles, we're not including either of them. So I'm going to go parenthesis, negative 2, comma, 3, close parenthesis. And that's my solution in interval notation there. All right, I'm going from negative 2 to positive 3, and I'm not including either the negative 2 or the 3. All right, let's look at another example here. So in this example, we can see the absolute value bars are not alone. So before I do anything else, let me make sure I get my absolute value bars alone. That's just like with our equations. We've got to make sure they're alone. So now we can see we got a little different situation here. Now I'm dealing with a greater than or equal to. So this is going to create a union. It's going to create two inequalities that are going, the numbers are going away from each other. So I'm going to be using my OR statement. All right, so I'm going to have x plus 2. How can I be further away than 7? Well, I can be greater than or equal to 7, or I can be less than or equal to -7. Those are the two ways I can be further than 7, more than 7 units away from 0. So I solve this here. I'm going to get x is greater than or equal to 5, or over here, x is less than or equal to -9. All right, so let's come down here on our graph. -9 obviously has to go on the left because it is the smaller of the two starting values. 5 is going to go on the right, so I'm going to throw my signs there. Now I'm going to have a closed circle at -9, and I want all of the numbers less than -9. Closed circle at 5. I want all the numbers greater than 5 there, right? So now I'm looking for a union. So I just want any number that's going to be a solution. So that means all of these numbers to the left of 9, including 9, and all these numbers to the right of 5 are going to be solutions here. It's a union. So how do we write this in interval notation? This is again what we go back to what we talked about with our compound inequalities, right? So the smallest value I'm going to have that's a solution is actually going to be -infinity. So this is going to be -infinity all the way up to -9. And notice here I am including -9, so I'm going to make it a bracket. Now I am combining that with all of the numbers over there. It's a union. So I'm going to put the letter U in between so that I know I'm actually taking both of these and sticking them together as one solution. Then I go to 5. Now I'm including 5. So 5 is going to be a bracket there. And then I'm going to have every number that is to the left of 5 is also going to be a solution there. And the largest I'm going to get to is positive infinity. So I'm going to close that with a parenthesis. And that is how I would write that in interval notation. All right. So, whoops. Let me erase that. Sorry, guys. I was thinking I was using a different program. Forgot how to scroll down here. All right, so now you got 2 there, 2 inequalities there, and 2 inequalities here that I want you to try on your own and come to class with questions. A, B, C, and D. A and B, the absolute value bars are alone. In C and D, the absolute value bars are not alone. So figure out what you got to do there. I want you to solve them. I want you to graph the solutions, and then I want you to use the graphs to write the solutions as interval notation. Again, if you got questions, please make sure we bring them to class, and we'll talk about them. We'll see you then.